In this video, I'll be working on lab number 11 from the Cisco CCNA lab guide, which is a free download from Flackbox.com. And let's take a look over here. It's Ospf configuration. So let's get started. Step 1, enable a loopback interface on each router. Use the IP address 192.168.0.x/32, where X is the router number. Okay, so we'll get started here. And router 1. Then we're going to go to global configuration mode, and we need to set up the interface for loopback 0. We'll hit enter on that. And then we need to set an IP address. And it's saying to use 192.168.0. whatever, and so 192.168.0.1 in this case. And we're going to have it's a /32, so it needs to be 255.255.255.255. If I could type, boom, there we go. Open that up just so it looks a little better. So we got the loopback interface set up. We're adding a 192.168.0.1. That looks right, so we'll hit enter. It wants us to do it on each router, so let's open up Notepad and copy these commands in. So we'll start off with configure terminal, paste that, and then we'll add the interface loopback 0, that one, and we will then add the IP address. And we'll copy that. I'm going to change the 1 to an X, so I remember to change it for each of the routers. That should be all we need. So to save time, we will just copy and paste this in at each router. Let's head to router 2, pull the command line, enter, paste, change the X to the router number, in this case 2. And enter. That's done. Router 3. We'll repeat the process. Change the X to a 3. 0.3. Let me open this up to make sure I didn't mess that up. 192.168.0.3. Yep. Okay, that's fine. And then we're going to go to router 4. Pull the command line up there. We will paste, change that X to a 4. That's done. And router 5. We'll do the same for that one. Paste it here. Change the X to a 5. Okay, that should be done. So when we enable the loopback interface on each router. Now it's saying to enable single area open shortest path first on every router. Ensure all networks except 203 are advertised. So we don't want to advertise this one, but we want all of these. And these are all 10 networks, 10.1. 2, 10.1.1, 10.1.0, 10.0.0, 10.0.1, 2, 3. So we'll just do for the 10 network in general. So let's go to, we're going to do this for every router. So let's open up Notepad again, and we'll save our steps here so we can cut and paste it. So to do that, we're going to need the router open shortest path first 1 command, because we're going to be working on that. And then we want the network command to be the all 10 networks, so 10.0.0.0.0 with a wildcard of 0.255.255.255, because again we want anything in the 10 network. And then this is going to be set for area 0. And we also want to add for the loopbacks, which, so we'll do one network 192.168.0.0, and the wildcard for that will be 0.0.0.255. And so we're telling it we want anything that's 192.168.0, regardless of this last number. And that should be in area 0 as well. And I think those are the only 3 lines we're going to need. Let's check it out. We'll start with R1. We're going to add exit. So we drop down to global configuration mode. And let's see how that works. So we paste here, exit, router OSPF1, network 10 and 192. Okay, that looks good. Let's move on to router 2. Paste, enter. Router 3, paste, enter. Router 4. And finally router 5. So enable single area OSPF on every router. That should be done. Okay, what do you expect the OSPF router ID to be on R1? Well, for R1, for all the routers, we set a loopback address. In OSPF, the loopback address, the highest loopback address is going to be the router ID. If a loopback address wasn't configured, then it would choose the highest interface IP number. So my guess is that the router ID is going to be 192.168.0.1. Okay, for router 1. So let's go over to router 1. And we're going to end, and we're going to show IP protocols. I think we'll be able to see that there. And there we go. So router ID is 192.168.0.1. There's the router ID. And that is indeed the loopback address. So that's confirmed. And step number 4, verify the routers have formed adjacencies with each other. Okay, so router 1 should have an adjacency with R2 and R5. And to check that, we're going to do the show IP open shortest path first neighbor command. And if we open this up a bit, we'll see that R1 does have an adjacency with 192.168.0.5, which is router 5, and 0.2, which is router 2. So it's forming an adjacency. I'm going to assume they all have, just to save some time in the video. I won't check each one individually though. The verify all 10 networks and loopbacks are in the router's routing tables. So we'll go back to router 1, and we're going to do a show IP route command. And let's confirm the networks are in there. So we have the 10.0.0 network, 10.0.1.0, which is this one, 10.0.2.0, 10.0.3.0. We have OSPF, which if you look at the codes up here, OSPF is O. And you have the 10.1.0.0 network found by it, 10.1.1.0, 10.1.2.0, and 10.1.3.0, which is down here. And then the loopbacks, 192.168.0.1, 2, 3, 4, and 5. So I'm going to assume that's all right on all the routers just to save some time again. So verify the networks and loopbacks are in the table. So we've done that. It says set the reference bandwidth so that a 100 gigabit per second interface will have a cost of 1. Not exactly sure why in this lab they want us to do that, because these are all fast Ethernet interfaces, but we're going to do it anyway. So to do that, we'll need to go to, we'll start with router 1, and we need to go into global configuration mode, and we need to be working on OSPF, so we need router open shortest path first 1, and we want to, we have to change the reference bandwidth for that. So the reference bandwidth, if a fast Ethernet is 100 megabits per second, 1 gig would gig Ethernet would be 1000 megabits per second, 10 gig would be 10,000 megabits per second, and 100 gig would be 100,000 megabits per second. So we need to change that. So we're going to do auto cost, reference bandwidth, and it's going to be 100,000. So let's open this up. 1, 10, 100,000, 10,000, 100,000 should be 5 zeros. Oop, 1, 2, 1, 2, 3, 4, 5. Yes, it is 5 zeros. So that will change that. And we'll hit enter, and it's saying it's changed. Please ensure it's consistent across all routers. So we're going to have to copy and paste that. So let's open up Notepad again. And we want these commands. So we can just quickly copy and paste them in all the routers. All right. And we will copy, minimize that. Router 1 is done. Moving on to router 2. Let's see here. Let's add exit. So we drop down the global configuration for that. Okay, minimize that. Let's paste it in. Enter, done. Router 3. That one's done. Router 4. That's done. And finally, router 5. That one's done. So set the reference bandwidth. Okay, so that's done. And it's saying, what will the OSPF cost be on the fast Ethernet links? Verify this. Okay, well, let's look. So we're going to look at, let's see, we need to do end, and we want to do a show IP, open shortest path first interface, because we need to see for fast Ethernet, and we'll just use 0, 0, and the cost is, let's find it. Here it is right here. I'll open this up a little bit. So cost is 1,000. Okay, so that's the cost, which, if that makes sense, because we set the reference bandwidth to 100,000. Fast Ethernet is 100 megabits per second. And for the cost in OSPF, it's the reference bandwidth, which we set at 100,000, divided by the interface bandwidth, which is 100 for fast Ethernet. The cost should be 1,000, and it is. Okay, so we've confirmed that. It says, what effect does this have on the cost of the 10.1.2 network from router 1? All right, well, let's look and see. And so we're going to want to look at the routing table. So show IP route. And we'll hit the space bar. And if we scroll back up to earlier when we issued that command, if we look at the 10.1.2 network, which is right here, there are two numbers. The first number is the administrative distance, and then the second number is the cost metric, or the metric, in this case cost, for open shortest path first. So it was 3, and now when we just issued it to the 10.1.2 network, we can see it is 3,000. So it went from 3 to 3,000. That's the effect. Okay, let's move on to number 9. For open shortest path first cost, it says there are 2 possible paths which R1 could use to reach 10.1.2, either through R2 or through R5. Which route is in the routing table? Well, let's go look. So to 10.1.2, it's via 10.0.3.2. So 10.0.3.2 is here. Here's the 10.0.3.0 network. It's going this way. which route is in the routing table. Okay, we answered that. Now it's saying change this so that traffic from R1 to the 10.1.2 network will be load balanced between both R2 and R5. So it wants it so that it goes both this way and this way. Now right now the cost is 1,000 per jump. So you have 1,000, 2,000 plus the interface at the end, another 1,000. The cost is 3,000 if you go this way. And then across the top it would be 1,000, 2,000, 3,000 plus the interface at the end, 4,000. That's why it chose this route. It's lower cost. So the cost is 4,000 to take this route. It's 3,000 to take this route. So we need to add 1,000 to this route basically to make it equal this one. So let's go and change these from 1,000 to 1,500 each, because that would be 1,500 and 1,500 would be 3,000 plus the final one of 1,000 would be 4,000, and it would equal that. So to do that, we need to go into router 1. We need to work on interface 1.1. And we're going to go to Comp T for global configuration mode. We're going to go to interface fast Ethernet 1.1. And the command is IP open shortest path first, the cost, which we're going to adjust to 1,500. And now we have to do that. So that's router 1. Now we need to go to router 5 and we need to work on this interface. And conf P for router 5, we want to go in interface fast Ethernet 0.1. And again, IP open shortest path first, cost, we want to make that 1,500. Okay. So we have this side done, 0.1 done. We need to work on 0.0 as well. So let's do that. So let's exit down a level. And we're going to go to interface fast Ethernet 0.0. And we're going to do the IP open shortest path first, cost, and we're going to make it 1,500. So that took care of router 1, both sides of router 5. Now we need to do it on router 4 for fast Ethernet 1.0. So let's go into router 4 and Comp T, interface fast Ethernet, and that should be 1.0, right? Yeah. So we have that done, and then we have to issue the command IP open shortest path first, cost. We want to make that 1,500. And if that's all done right, we should see now 2 routes in the routing table from R1. So let's end, and for our, we'll do the show IP route so we can look at the routing table. And we're looking for the 10.1.2 network, which is right here. And now you can see 2 paths, 10.0.3.2, which is this way, and 10.0.0.2, which is across the top. They both have a cost of 4,000. So it will split it and load balance. So that's number 10 is done. Number 11, verify that the traffic is load balanced. Okay, we just did that, so that's fine. Now we're into default route injection. Number 12. Ensure that all routers have a route to the 2030 network, which is over here. Internal routes must not be advertised to the service provider, which is here. So we're going to have to create a passive interface so that although traffic will flow this way, router 4 will not share any internal network information with the internet service provider. And that's a security thing. So internal routes must not be advertised, right? So we're going to create a passive interface on router 4. So let's do in and Comp T, and then we're going to work on open shortest path first, so Ospf 1, and we want to set up a passive interface for FA11. Fast Ethernet 1.1. Yes. And now we want to ensure that all routers have a route to 203.0.113.0. Okay, so let's add that. And we can do that by adding the network 203.0.113.0 with a mask of 0.0.0.255. And we want that to be area 0, because everything's area 0 right now. Okay. And it says ensure that they all have routes, so that should be there. And then verify that all routers have a path to the 203 network. Okay, well, let's go look. And we'll do a show IP route to look at the routing table. And there it is. Yep, okay, that's done. Now it says to configure a default static route on router 4 to the internet via the service provider 203.0.113.2. So we need to go over here. We need to configure a static route out this way, right? Yeah. Let's do that. So on router 4, const t, and router 4, we're going to set up a default static route. So the command for that is IP route, and then we want it to be the default. So 0.0.0.0. You're just saying, hey, any route you can't find another way, go this way. 0.0.0.0 for the subnet mask. And the next hop will be the ISP over here. So that is 203.0.113.2. Okay. So we've created this route that is basically saying, hey, if there's anything you can't find and you don't know where to send it this way. And we're going to need to make sure the other routers know about this, though. So we have to go into Ospf again. So Ospf 1. And we want to command as default information originate. And that should send out the information letting the other routers know. That should be all we need to do for that. So let's go back to, we'll just say router 2 and do show IP route. Let's look at the routing table on router 2. And sure enough, so you have this out to the 203 network, plus you have the default the static route that we created, and you should see up here the gateway of last resort is now set. So that took care of that. That was number 14 and 15, so they do know how to get to the internet. And 16, I guess. Verify. So we verified it for R2. I'm not going to do it for all the routers just to save some time. So I think that's complete. Now we're going to go to multi-area open shortest path first. So 17 says convert the network. So this is just a picture of this. As you can see here, it's the same thing. Convert the network to use multi-area open shortest path first. R3 and R4, which are here, should be backbone routers. Okay, since they're in area 0 and all their interfaces are in area 0, that are backbone routers. R1 needs to be a normal router, so that's going to be over here in area 1. And R2 and 5 are going to be area border routers, as shown in the diagram below. Then you save your changes to the startup config and reboot. Okay, so R3 and 4 should be background routers. We don't have to change anything for them because they're already in area 0. Then it's saying R1 needs to be a normal router in area 1. So let's start with that. So we'll go to router 1. It'll pull up. All right, so let's start by doing a show run, pipe it out to the section beginning with Ospf, and we'll see that for router 1, we have area 1 for the 10 networks, and the 192 networks are in area 0. Excuse me. So what we need to do is change this to area 1. And yeah, that should be all we need to do for that. So let's go to conf t and let's do router. We're going to work with open shortest path first, 1. And we want to issue the command network. We're going to change this one. Actually, I can just cut and paste that. So we're going to take this and we're going to copy, we're going to paste, and I'm going to change that from area 0 to area 1 right there. That should take care of that. Yep, change from area 0 to area 1. And now let's copy. Oops, it's running all kinds of stuff. Let's copy and paste this one. Well, let's just try one more time. Let's get up here. Where'd it go? There it is. Quickly. Nope, I'm not fast enough. There it is. Yeah, I'm just going to have to type it in. So exit to drop down a level, and we need to do the same thing. So network for the 192.168.0.0 network with a mask of 0.0.0.255, and we want to put that in area 1 now. I made a mistake. Oh, I'm in the wrong section. I need to do router, open shortest path first, 1. Then I need to type in network 192.168.0.0, 0.0.0.255, and we want that in area 1. Okay, there we go. Change from area 0 to area 1. So that should be all we need to do for router 1, and it said to save your changes to the startup config. So we will do an in, and we'll do copy run start to copy running configuration to startup configuration, and then reload because it says to reboot the routers. So we're going to hit yes. I'm going to jump forward in time a little bit and packet tracer so we don't have to just watch that. There we go. So router 1 should be complete. Now we have to, router 2 and 5 are going to be area border routers. Okay, so what we have to do for router 2, well, let's look at router 2. And no, that's router 1. Router 2. And let's do a show running config pipe through the section command for Ospf. So we have router 2 has all of the 10 networks in area 0. And right now, we need to change that so that it has the 10.0 networks in area 1 and the 10.1 networks that stay in area 0. So we're gonna have to get rid of this line, I believe. We need to change that. So let's do, yeah, let's, because that's too broad. That's all 10 networks. We need to break them into 2 sections. So we'll copy. We're gonna go down for router 2, we got to go into global configuration mode. We're going to be working with Ospf. And now we want to copy and paste that. So no, and then we'll paste the command for the network for all of the 10 network. Let me open this up. So no, we don't want all network 10s to be in area 0 because we have to split that. So that should take care of that. Now what we need to do is we need to break so that the 10.10 network is in area 0 and the 10.00 network is in area 1. Yeah, so let's do that. So network, and we want the 10.1.0.0 to be, got to have the wildcard. So 0.0.0 dot, no, yeah, 255. Right, because we want the 1010 on in area 0. Okay. Yeah, that's right. It has to be in area 0. So I need to say that it needs to be in area 0. So add area 0. So that should put that over there. Now we need to do the same thing for the 10.0.0.0 network over to the right, which is area 1. So 10.0.0.0 should be in area 1. And so 0.0.0.255, and we want that in area 1. Right? Yeah. Okay, so that should be done for router 2. So let's save our work, copy running config to startup config, and we will reboot. So let's reload. We'll hit enter. I'm going to pull this over. I'm going to jump forward in time in packet tracer so we don't have to sit there and watch that. Okay, so we fixed router 1. We took care of both sides of router 2. So we need to do the same for router 5. And let's go end. And for router 5, again, let's show run. Pipe it out to section, open shortest path first. And we see all 10 networks on router 5 are now in area 0. So we need to break that apart just like we did with router 2. And so let's go to comp T for global configuration. Router, we're going to be working with open shortest path first. And we want to say no network 10.0.0.0, right? Because that's currently set up for anything that's in the 10 networks is in area 0. So we need to get rid of this line, basically. I could have just copied and pasted that. We need the mask, or the wildcard. So that will be 0.255.255.255. And currently it's in area 0, and we're saying no. So we're going to undo that. And now we need to break router 5. We need to say, okay, so we pulled, everything 10 was in area 0, so we pulled that out. Now we need this side, the 10.0.0.30 network to be in area 1, and we need the 10.1.30 network to be in area 0. So like we did with router 2. So, yeah, let's do that. So router 5, let's hit end. We're going to go comp T, we're going to do router, we're going to be working with them shortest path first. And we want to go to, add the network 10.1.3.0, 0.0.0.255, and we want that 10.1.3.0 to be in area 0. Okay, so let's go ahead and say area 0. So 10.1.3.0 is in area 0. And then we want to do for 10.0.30, so 10.0.3.0, with the wildcard of 0.0.0.255, and we want that in area 1, right? Yeah. So do that, and we need to save our work. Copy running config to startup config, reload, because we're going to reboot it. Proceed, yes. So we'll jump forward in time 30 seconds, and that's done. So I think that's all we needed to do. Convert the networks. R3 and R4 staying the same. They're going to be backbone. We didn't have to change anything with them. Changed R1. We split R2 into basically 2 camps, area 0 and area 1. And that should be all we need. So let's do the show IP open shortest path first interface command, and so this is router 500, fast Ethernet 00, it's area 0, and then 01 here is area 1. Okay, so I think that's done. Okay, moving along. All right, verify the router's interfaces are in the correct areas. I did that. Oh, I didn't do it on router 2 though. So router 2, let's do a show IP, open shortest path first, interface command, and we're going to back up here a little bit. So router 2, let's open this up, and we have for router 2, fast Ethernet 00 should be in area 1. So here's 00, it's in area 1, and 01 should be in area 0. So where is fast Ethernet? So 01 is in area 0. There's 01. Yep, there we go. Okay. All right, we verified the router's interfaces are in the correct areas, so that's good. We verify the routers have formed adjacencies with each other. Okay, well, let's go ahead and we'll just look at router 1 for that. And the command is going to be show IP, open shortest path first, neighbor. See who its neighbors are. So you have router 1 has an adjacency with router 5 and router 2. So that looks good. I'm going to just assume everything's okay with the rest just to save some time so we don't have to go through every one. So what change do you expect to see in router 1's routing table? Verify this. Give the routing table a few seconds to converge. I don't know. So let's look. Let's just pull this up and do a show IP route. And we'll hit enter. Okay, so, and it's saying, what change do you expect to see in R1's routing table? Okay, well, let's look at it. Well, this is different. So you have, from the codes, you have O is OSPF, and IA is inter area. So it sees from router 1, the 10.1.00 network, 10.1.00 network. Right, because we changed, remember we changed, this became area 1 over here, and then this way became area 0. So that changed. It now sees them as IAs, inter area. Where'd it go? Somewhere up here. There it is. IA, OSPF inter area, because they're in different, router 1 is in area 1, and 10.1 network is over here in area 0. Okay. I think that's pretty much it. It's just showing the IAs now. All right, so do you see less routes in the routing table? Why or why not? Well, I'll let that open. Let's take a look. No, everything, I mean, they're the same. It's the 10.0, 10.00, 10.10, 10.20, 10.30, and then you got the 10.10, 10.11, 10.12, 10.13, and the loopback. So no, there are not less routes in the routing table, and that's because we have to do summarization if we want there to be less routes, because OSPF won't do auto summarization. We have to configure summary routes, which is, I figured that out by looking at this. Configure summary routes on the area border routers. So yeah, that's the thing. All right, so let me see here. Move my glasses over here. And configure summary routes on the area border routers, which are these two. for the 10.0.0 networks, which is over here, and the 10.1.0 networks, which are over here. Okay, configure summary routes in the area border routers. So R2 is an area border router, so let's start with it. And we're going to go to Comp T, and we're going to go into, we want to work on OSPF. So OSPF 1. And we need to, so if we remember, move this over here. This over here is area 0. And that, so we want everything, these are all 10.1 networks over in area 0. So we're going to create an area 0 range, which is the 10.1 networks, 10.1.0.0, with a mask of 255.255.0.0. So we're just saying, hey, anything 10.1, we want to create the range for area 0 of anything that's 10.1 for the summary route. So area 0 is going to have all the 10.1 networks as a summary route, is kind of what we're doing, I think. I think that's right. Yeah, it looks like it took it. Now we need to think in terms of so we did it for area 0. We need to do it for area 1, which is all 10.0 networks. These are all 10. So remember, area 1 was this way, and it's all the 10.0 networks. So let's do the same thing, but for area 1. So area 1, the range will be 10.0.0.0.0 and 255.255.5.0.0 because it's all the 10.0 networks. Okay. And we did it for R2. The other area border router was R5. So R5, we need to do the same thing. So let's go to Comp T, and we're going to work on open shortest path first. And we want to create area 0 was all the 10.1 networks, right? So area 0 range is going to be 10.1 dot anything. So 255.255.0.0. And then on the other side was area 1, and that was the 10.0 networks. So we're going to do area 1 range, 10.0.0.0, 255.255.0.0. And let's okay, so let's look at, let's do a show IP route. Let me see what that did. Doesn't look like it did anything. Let's see. Or do I need to be looking at it from the perspective of R1? Let's see here. So this is what the routing table looked at before I made the changes. And so we're wanting to get summary routes out of this. So show IP route. And I don't see that. What, did I do something wrong? Okay, configure summary routes on the area border router. So 2 and 5 were the area border routers for the 10.0 and 10.1/16 networks. You shouldn't have to, you should only need to create the summary routes on the area border routers. So why does router 1 not see that? I don't know. Let's look at it again. Unless it just hadn't propagated yet. Oh wait, there it is. Okay, look right here. So here's the 10.1 network /16. Router 1's got it now. I guess it was just hasn't updated yet. Do it again. There's one of them. So there's the 10.1 network. And okay, so I guess it's just a little slow to propagate. So verify R1 now sees a single summary route for the 10.1 network, which we did. We'll open this back up. And there it is. Single route for the 10.1 network. Okay. Verify R1 is receiving a summary route for the 10.1 network from both R2 and R5. Okay, so we need to look at the routing database here on R1, right? So show IP open shortest path first on database. And we want to see summary route from both R2 and R5. So here's space key from R2 and R5. So here's summary router links to, so this, here's R5. Link ID. I'm not really sure. Verify R1 is receiving a summary route for the 10.1.0.0 network. So it looks like, oh, okay, yeah, it is. Look. So 10.1.0.0, 10.1.0.0. One is coming from router 5, and one is coming from router 4. They're right there. Okay. So that's number 24. And it says R1 traffic, is routing traffic to the 10.1.0.0 network. 10.1.0.0 network via R2 only. Why is it not load balancing the traffic through both R2 and R5? Well, because remember we changed the cost of this path to 1,500 and this is only 1,000. I think that's why. So yeah, that's what it is. It's just the cost would be higher to go this route, 1,500. That's 3,000, 4,000. Whereas this way, it's what, 2,000. Okay, I think that's the answer for that. So we're moving on to number 25. No, we did 25. Okay, so designated router and backup designated routers. So we're going to be working with this little tiny network over here now. And it's saying enable a loopback interface on router 629.6789. Use the IP address 192.168.0.x convention. All right, where X is the router number. So let's pull up our, we're going to start on router 6. We're going to go to command line. And let's pull up our notepad because we're going to be doing it on all of the routers, right? Enable loopback on routers R6 through R9. Okay, so yeah, then we're going to need to go to, so we're going to need enable, we're going to need comp T to get a global configuration mode. We're going to need to add the interface, so interface loopback 0. We're going to need an IP address for the loopback, so IP address will be 192.168.0.x, depending on what router we're working on. And since it's a loopback, we're going to do a /32, 255.255.255.255, and that should work. So let's copy that. Let's paste it over here on router 6. I need to change this to, I don't know if that's going to work. Hold on. Something went wrong. All right, let's try it again. Well, here, let's do this. Let me make sure I clean up any mess that's here. So conf t, and we want to have interface loopback 0, and I want the IP address of 192.168.0.6 because this is router 6. And 255.255.255.255, since it's a loopback, it's going to be /32. Let's go to router 7. And we need to do the same setup there. So I'm going to just copy these through. Something went wrong when I did it the other way. And we're going to paste. We got that. And then we need to paste this line. And change that X to a 7 in this case. That should be done. Let's go to router 8. And we're going to pull up these three first. Command line. Enter. Paste those. Enter. We're going to do this one. Paste that and change the X to an 8 for this one. Okay, that one's done. And then finally router 9. Let's just do the same thing. And command line. And we will paste that. Hit enter. And then we're going to change, we're going to add the IP address finally. And we have to change that X to a 9. And that's done. Okay, so we'll minimize this. So we are on 26. Enable loopback interface on router 6 through 9. We did that. So step number 27 is enable OSPF for area 0 on the loopback 0 and fast Ethernet 00 interfaces on routers R6 through 9. Okay, so we need to enable it on area 0, for area 0, on the loopback, and the fast Ethernet. So let's pull up our notepad again because we can cut and paste this. So let me start with router 6 first so I can see what I need to be typing in here. Let's go in, conf t, and then I want to work on OSPF, so router OSPF 1. We're going to be working with OSPF. And we want to enable OSPF for area 0. Let me think about this for a second. So we need to do, hold on, do show IP interface brief. Okay, hold on. Okay. So 172.16 is fast Ethernet 00. So 172.16 is the network. And then loopback was 192.168. That's the network for loopback. So if we're going to have OSPF on there, we need to let me think about this for a second. Copy. We need to be working with OSPF, and we need that network, the 172 network, right? So network of 172.16.0.0 with a wildcard of 0.0.0.255, and it wants us to put it in area 0. Area 0. Right? Yeah. And then we need to do for the loopback. Okay, so then we need to do network 192.1.168.0.0, and its wildcard is going to be 0.0.0.255, and that should be area 0. Okay, so, and it's saying do it for routers R6 through 9, so I should copy this to Notepad. So let's grab this line. We're going to need that one. And then we're going to need the network 172 line. And we're also going to need the 192 network line. We need that one. Okay, and we'll paste that. And we're going to copy that. And we're going to go to router 7. T. And we're going to do paste. Okay, that should be done. And then router 8. So router 8, we're going to get the network information and all that in there. And then finally router 9. I'm going to paste that. Oop. Oh. Let's see, I made a mistake. Opt T, then paste it. There we go. And then hit enter. Okay, so that should be number 27. Enable OSPF for areas around loopback and past Ethernet. Okay. 28. Set the reference bandwidth on routers R6 to 9 so that a 100 gigabit per second interface will have a cost of 1. That's just like where we did before, when we did the 100,000. So let's go to router 6, right? Because it's 100 gigabit. Yeah. Okay, so we're gonna hit enter, and we're gonna go end, and we're gonna copy, and we need to work with open shortest path first. Okay. And we need to do that auto cost stuff. So auto cost, this is the reference bandwidth. Let me open this up a little bit. So 1, 10, 100,000, 10,000, 100,000, should be 5 zeros, yep. And hit enter. It says bandwidth is changed. Please ensure it's consistent across all routers. So let's pull up our notepad again. Let's grab this line. Paste it here and grab this line, and we will paste it here. So that was router 6. Let's move on to router 7. And Alt E, let's paste that there. Okay, router 8. And paste that there, and router 9. Pull that up, and we'll paste that one there. Okay, so that looks good. All right, so set the reference bandwidth. Okay, we did that. Okay, which routers do you expect to be the designated router and the backup designated router on the Ethernet segment? Let me see. So the designated router should have the highest loopback address, and then the backup designated router should have the second highest, because we did set the loopbacks. And when we were working with the loopback, let me do this. Look at do show IP interface brief, and the loopbacks were 192.168.0.x, x being the number of the router. So my guess is R9 will be the designated router, and R8 will be the backup designated router, because they have the highest loopback numbers. They have their loopback address numbers are the highest. So that's my guess. So let's look at it. Let's look at R6 and do an end, T. And so we need to see the interface. So show IP open source path. I'm in the wrong place. Show IP open source path first. We want the interface fast Ethernet and 0, 0. And let's see what it says. Let's open this up. Okay. Designated router is, no, I was wrong. So designated router that's interesting. I wonder why. It looks to me like it's saying the designated router is 6 and the backup is 7. But, okay, so I could be wrong about how it chooses the designated router. Clearly I am wrong about how it chooses the designated router. I thought it was by the loopback number. I'm really not sure. So, off to number 30. Set R6 as the designated router without changing any IP addresses. Well, R6 already is the designated router. Hold on, let's do this. Let's go to R9. And we'll do end. And on R9, let's do show IP, open shortest path first. We want to see the interface FA00. And yeah, sure enough, designated router is 6 and backup is 7. That's weird, because if it's wanting to set R6 as the designated router, it tells me in my packet tracer it did something different. I don't know why. All right, so set number 30, set R6 as the designated router without changing any IP addresses. So let's, instead of making R6 the designated router, let's do it with R9, because R6 already is the designated router. So we need to configure a higher priority for R9. So let's go to Comp T for global configuration. And we want to go to interface fast Ethernet 0, 0. And IP, open shortest path first, and then priority, there it is, oops, priority, and we're going to, I think if you set it as 100, let's see what it does, and then end, and then we're going to go clear. We need to clear the OSPF, so clear IP OSPF process, and yes, we want to do that. And I think we'll have to give that a second to get all the information back up. So let's do, yeah, see, it's coming up now. But let's do a show IP open shortest path first, interface fast Ethernet 0, 0. Let's look at it now. And designated router is now 192.168.0.9. So the backup designated router just stayed the same as 7. 6 and 9 changed. And verify R6, or in our case, R9 is the designated router. And that's it. That ends this lab. Lab number 11, I believe it was, working with OSPF from the Flackbox manual. And I hope you enjoyed it, and I'll see you in the next video.